projection of lines. So let us begin. So as we know, this is an important diagram. It is known as a master diagram. You need to remember this diagram in order to solve any example based on projection of lines. So there are a total of 10 details in this diagram. You should remember this 10 of the details in order to easily solve the diagrams. But always remember that theta and alpha are always taken with a dash. Phi and beta are always drawn from your point A. B dash and B1 dash is always on the same locus line, and B and B2 is always on the same locus. And always remember, your true length is never rotated, and top view and front view are rotated in order to get your true length, right? So let us begin with our very first example here. So let us begin. Now the line is in now profile plane, means a plane perpendicular to both HP and VP. So we are introducing one new plane which is known as a profile plane. So let us understand it by a pictorial representation. So this is our vertical plane, this is our horizontal plane. Now we are introducing our third plane. As you can see, our third plane is perpendicular to both HP and VP. So this is nothing but our profile plane. So our line would be now in our profile plane, and thereafter we are solving this example. So how to solve the example? So as you can see, our line is now in profile plane line AB. So this is a 3D representation of your object. So let us convert it into 2D clear understandable views. So first we'll be taking a front view of this object AB. So we'll be having a front view as a shorter length of line in VP, as you can see. As your line is inclined to a VP, that means we'll be having a shorter length of line as a front view in VP, which is denoted by A dash and B dash. Now let us take the top view from the top direction, as you can see. So you will be having a shorter length of line in top view itself. So this line would be of AB. So now as you can see, your line is inclined to your HP at an angle. That's why you will be having a shorter length of line in HP itself. So now thereafter what we'll do is, this is a 3D representation of your line into your quadrant system. So let us convert it into orthographic views, a 2D representation. So let us first draw VP, then HP, and then profile plane. Thereafter let us plot this XY line, and then we'll start to draw the first view, which is a front view, which is A dash, B dash. Then after we'll plot the top view, which is A and B. Now what we'll do is, we'll try to draw a vertical line from this line in order to show that our top view and front view are both in the same line. Then after, let us draw rightward lines from your front view. Let us draw rightward lines from your top view. Now if we need to find out the views in profile plane, we need to follow this course here, in which what we'll do is, we'll try to take the radius of this portion into a rounder, put this point as our center, and take the radius equal to this and try to draw one circular arc. And once again, take radius is equal to, starting from this point till this point onto your rounder. Take this point as the center and this point as the radius, draw one circular arc. By doing this, we are actually transferring this vertical dimension of your top view exactly onto your profile plane. We are transferring, and then after we'll be drawing vertical lines, as you can see. And then after, by intersection of the vertical line from this rotational lines and the horizontal line from your front view, we'll be having one view generated, which is nothing but A double dash, B double dash. Since this view is on profile plane, that's why it is denoted by the side view, or you can say A double dash, B double dash. It is making certain angle with your XY line here. So it is nothing but your line's angle with your XY line, or you can say with HP. So that's why it is known as theta. And the angle made by this line with VP is known by phi. So this is the representation of line. Whenever the line is in profile plane, it must be inclined to both of the planes by theta and phi. So now here we have some resultants to remember. So here top view and front view both would be the vertical line whenever the line is parallel to profile plane. The side view will show a true length. As you can see, you are getting the line's true length because it is obvious that line is parallel to profile plane. That means we'll be having a true length of line in your profile plane itself. And here the summation of theta plus phi, the angles of your theta plus phi, the angles of with respect to HP and VP would be 90 degrees. It is obvious because this is 90 degrees. So this angle's summation must be a 90 degree, right? So let us move ahead. Check out one example. Problem number 1. A line AB 75 mm long has one of its edge A in VP one of its end A in VP, other end B is 15 mm above HP and 50 mm in front of VP. Draw the projections of a line when the sum of its inclination with HP and VP is 90 degree. Means it is lying in profile plane. Find the true length with the reference plane. So here, let us first write down the data. So here true length is given 75 mm, theta plus phi is already written 90 degree. Point A is given, which is in HP, and point B is given, which is 15 mm above HP and 50 mm in front of VP. So let us start drawing this example. So in this example, as you can see, let us first draw the quadrant system by drawing XY line and vertical line. So this will be profile plane. These two are your HP and VP. Thereafter, let us draw one vertical line onto which we'll be having our front view and our top view. So here it is said that point A is in VP, so that means your point A would be on XY line itself. Then after, let us locate point B, so which is 15 mm above HP, that means B dash 15 mm above XY line like this, and 50 mm in front of BP, that means you need to draw point B 50 mm just below your XY line like this. Then after, what we'll do, we'll try to draw horizontal line from this B, and we'll try to locate the position of your side view of point B, which is B double dash. So we have located this point B double dash. After getting this point B double dash, what we'll do is we'll try to draw one line of a true length. So what is the true length? Dimension 75 mm. As we know, if the theta plus phi is equal to 90 degree, that means what? The line is parallel to profile plane, and for that case, the true length of line would be shown in what? Profile plane. So from B double dash, we need to plot 75 mm. So let us take out our rounders. Adjust 75 mm on your rounder and put your rounder at B double dash and try to cut your vertical line of your VP, and we'll be having this point, which is nothing but your A dash point, which is 75 mm away from your point. So this will be your point A double dash. Ready? Now to find out your point A dash, we need to draw a horizontal line from your A double dash and vertical line from your point A, and we'll be having this point as a A dash. So now let us make this line darker. So we'll be making this line darker. This is nothing but your front view because it is laying in your VP. So let us make it darker. So this is now your front view. And the below view, it is lying on your VP. So below view, it is lying on your HP. That's why it is known as your top view. And as you can see, these are the points which are without dash. That means you are having this as a top view. So this is nothing but your side view because it is into your profile plane. So this is known as your side view, and it is of a true length. Very easy. So you can solve any of the example based on your profile plane now. So the angle with respect to HP, if you find out, you will be having theta, and if you find out the angle with respect to BP, you will be having that phi. Right? So here it is asked that you need to find out the angle with each of the reference planes, so you can find out by this method. So now let us move it to problem number 2. So here endpoint A of a line is in HP and 25 mm behind VP. Endpoint B is in VP and 50 mm above HP. And the distance between end projector is 70 mm. Draw the projections. So first let us understand this problem. So here 2 points positions are given. So point A is in HP, as you can see, 25 mm behind VP, and second point B is given, which is 50 mm above HP and in VP. And the new data which is given, which is distance between end projectors. In short, you can write down DBEP, which is given as 70 mm. So first of all, let us draw first the XY line. So let us draw XY line. Thereafter, let us draw one vertical line in the position of your A. Thereafter, as we know, distance between end projector means it is the distance between projectors of A and B. So let us take the distance between end projectors as 70 mm and try to mark this point on your XY line, and from that point let us draw one vertical line on which the projectors of B would lie. So now let us start with point A first. So here point A is in HP, that means A dash will be on XY line, as you can see. And point 25 mm behind VP, that means point is 25 mm above XY line from the projection of point chapter. So this is a point 25 mm above XY line. Then after point B is 50 mm above HP, that means point B dash would be 50 mm above HP. and point B is in VP, so that means point D would be on XY line itself. So point B dash 50 mm above HP and point B is on XY itself because it is in VP. So we are having 4 points. Now let us connect the 2 points with the dash and let us connect another 2 points without dash. So the dash points connected are known as the front view and without dash points connected are known as top view. So let's see, we are having 2 things, top view and front view. So what we can do, we can rotate this top view and front view and make it a horizontal line in order to get our true length, right? So now let us convert this any one of the top view or front view as a horizontal line. Before that, let us locate the locus. So it is a locus of B dash or B1 dash from your point B dash, and from point B you know the locus of B or B2. Now let us try to convert and rotate this top view first. We will be taking the dimension of AB on our rounder, take A as a center, AB as a radius, draw one circular arc in order to make this true length, in order to make this top view a horizontal line like this. Then after let us draw one vertical line from that point, and the vertical line touching to the locus will give a point B1 dash. So after getting B1 dash, let us connect this point of dash with the point A dash. We will be having a true length A dash B1 dash, right? Thereafter, very easy, take the dimension of your true length and take the dimension of your true length onto your rounder and put your rounder at position of A and try to cut this line of locus B2 and you will be having your true length generated. In other method, what you can do is you can take the dimension of A dash B dash on your rounder, put your rounder at A dash and take the radius of A dash B dash and try to draw one radius like this. You will be having this radius intersected on the locus of B or B2 and this will give you a point B2 here, and after getting your point B2, it is very simple. Try to connect this point B2 directly to your point A, and which is nothing but your true length. So very easy. So we are following the same example, but here the method is different. So what we are having true length. So here it is given top view and front view are given. So that's why we are rotating and making it a horizontal line, and then after we are trying to find out the true length, right? So that is all from my side. If you enjoyed my lecture and teaching style, do not forget to like, share and subscribe to my video. And if you have any doubts, any queries, feel free to comment down below. Keep learning, stay connected. Bye-bye.